In this video, we're going to go over the use case, sending frames on timer period. Here we'll be using the 100 millisecond timer use case and pointing out some of the implementation differences between PIC and AVR. Note, we are essentially going to refactor either the data streamer continuously send frames or using a custom struct use cases, so you can use either as a starting point if you want to follow along. But we'll set up a timer of 50 milliseconds instead of 100 just to ensure that we have something different than the previous examples that we are refactoring. So this use case is basically about using a timer to set a flag to send a frame to the data visualizer. So a key new step in this use case is to add a timer to your project and follow the instructions for a 100 millisecond timer. So here we could look under plibs and TCA since we're using an AVR, or timer 0 if we're using a PIC. We will have slightly different instructions if we're using a PIC, an AVR, or DSPIC. In all cases, we'll select a LED and toggle it at 100 milliseconds. Note that the global interrupt enable is a system setting in the AVR. While looking at the PIC, the global interrupt enable is done in code, and the low frequency internal oscillator is independent of the system clock. Functionality you'd typically find in the RTC on the AVR. Besides that, the code is pretty much identical. So here we're going to be refactoring this use case to use, instead of basically a delay, we're going to trigger this frame update using a timer. So we go back to the builder. See, we need to add a component for a timer. So under device resources, timer, we can choose any timer, but we'll select TCA. Select a system clock divisor so that we can get up to 50 milliseconds. We want to change it from 100 just so that it's different. And overflow on timer interrupt. So we see the notification to enable interrupts. Global interrupt enable. That notification goes away. As mentioned, for PIC, you'll uncomment a line in main to enable global interrupts. We can generate code. So we can come into main, and in our timer, whichever timer we're using, at the top of the timer we'll find a construct timer interface, and the way we set up the 100 millisecond timer or whatever frequency timer is we'll create a pointer called timer of type timer interface and set it to the address of our particular timer interface. This enables us to access the portable API of the timer, and our timer callback, we're going to actually just set that equal to the data stream frame update, and then we don't need to call this from the while loop, and we can remove our delay. So now, if all goes well, we'll be able to program the part. But before we look at the current data, we can see that currently we have 112 milliseconds, which is both the 100 millisecond delay and the time it takes to send the frame. As we show live data at the beginning, we can see the programming happening, and we'll remove the cursors, zoom in a bit, and add a couple more. And yes, that looks like it has worked correctly.